supply chain analytics. Today, we will be discussing on supervised learning technique, and in supervised learning technique, we will be looking at decision tree. Okay. Let me share my screen. Okay. So decision tree is a supervised learning technique. Okay. That can be used for both classification and regression problems, but it is mostly used for classification problems, right? It is a tree structured classifier. Okay, you have these nodes represented as the features. Okay, and the branches are represented as the decision rules. Okay, in decision tree, you have decision node as well as leaf node. And of course, you have different branches as well. Decision nodes are used for decision making if you are making any kind of decision. Okay, whereas your leaf nodes, they are used for the decisions which do not have any kind of a branches. Okay, and it is called a decision tree because it is like a tree like structure. Okay, it is asking like a simple, you cannot say it is like a fish structure, but you will have certain elements like true or false, yes or no kind of decisions. Okay, so you can part the data into, okay, and this is a algorithm that will help you construct a upside down or a down to top model. Okay, you can split the model, split the data, and it will also help you decide when to stop the split. Okay, and in making the decision tree, you have the list of the data, that is, you have the data set. Okay, you calculate the uncertainty, right? And then you get to partition the data as well. To partition your rows into true rows and false rows. And then what you do is you gather these questions and choose from whichever questions is giving you the highest information or a maximum information. Okay, and you also can look at, in decision tree, you can look at categorical data as well as numerical values, numerical data, right? So the data required will be limited, very less data can be used. It doesn't have to be a huge data, right? It is easy to handle. Like you can manage around and well understandable. Okay. And whenever you are tuning, okay, the, for example, hyper tuning parameters, you need to be mindful about that. Okay. That is one point. And the other is it can resist the resistance of outliers is high. Okay. That means when you are into the data pre-processing stage, it does not require much of data pre-processing. Okay. You'll find very low numbers of outliers in it. And if you talk about the, let's say, the drawbacks, I would not say as drawbacks. However, if you look at that side, there are few chances of overfitting models, right? And these overfitting can also be avoided. What you do is you need to choose the right features, I mean branches that you feature on. You need to make right use of the features. Okay. And the smaller the tree, the smaller the error. Okay. That is one point. And with decision tree, cross validation error is one standard error or a minimum error from that. Okay. So what you do is in each stage, you split the tree. Okay. You check on the cross validation error. Okay. And you might, if you stop for the underfitting, or you can stop at the right moment for overfitting. Okay. That will add on to the decision. So the number of splits increases, the chances of reducing the error is significant. Okay. And how do you apply decision tree and machine learning algorithm in the supply chain analytics? How do we get to know that? How do we choose? You can do with the help of, let's say you have a shipment to do. Okay. Is your slot available or not? Okay. You need to look at the logistics point, right? Is the slot available or not? Okay. Let's say you want a shipment done on that particular day in a week's time, right? Is it possible? Will that shipment take long enough to reach the destination in that particular time frame? Okay, and how is the shipment happening? Is it through air? Is it through a truck, or what is the mode of transportation? Okay, right. And surrounding this, there is also cost featuring. There includes cost of the shipment as well. You might, for example, okay, how about now?
Not yet, still, sir.
Okay. Yes, yes, it is. It is there. Okay.
On my site, it's just showing decision tree 360 DigiTMG
Yes, yes.
only.
Yes, I am on the
Oh, it's
same
just,
client. I am on the
okay,
same slide. Yes.
okay, okay.
Okay. Okay. If you have any questions, you can go ahead or you can remain on mute. All right. Thank you. Let us continue. And like I said, the cost will also have, if you go for a express shipment, or if you want a delayed shipment or something like that, right? Budget constraints basically. Okay, you might want to afford a higher price for the shipment, and that can be done quickly. Or if you are low on a budget and you can wait for that time frame, a week's time, or a standard delivery, standard shipment of that sort of decisions. Okay. For example, you want a package, a presentation for a friend. Okay, you're sending a gift to your friend, or you are you want a vehicle to be booked and delivered to your friend's place right away, and you're planning a surprise. Okay, do you have the car with you purchased? If it is yes, what is the delivery time? Okay, what is the delivery time and how much does it cost? Let's say yes, you have, you look at the budget as well. Okay, let's say you have, say, $100, and then you will look for the options. Okay, what are the charges for the standard delivery, or what are the charges for the express delivery, kind of thing. Okay, if you go for a express delivery, what will it cost, right? And if you are going for a express delivery, what is that you do? You spend a certain amount comparatively, compared to that of a standard delivery charges. Okay, and if you can afford the express delivery, you will spend a certain amount. Or if you do not have that budget, let's say you do not have $100 as your budget, you will go with alternative options. Like you might go personally and deliver along with the logistics team, or you might want to send it across with a friend, which will take longer hours. However, it might not cost you that much amount, right? Okay. Similarly, you can also look at the other alternatives, right? That is, in one way we can look at the nodes, decision nodes and leaf nodes. Okay. For example, you have a 3-day off and you're planning for a holiday. Do you want to go for an holiday or not? If yes, what will be your budget? And if you have a budget, what are your options? That way your branches, I mean your leaf nodes will elaborate, right? And then you you keep, doing this, you keep splitting these options. Okay. Subsequent splitting. Decision node is also called as root node. Okay. In decision node, you have the decision node, and in one decision node, for example, let's say this is your decision node. Right. And this decision node is also called as root node. And this is a decision node. This decision node will have leaf nodes. Okay. These are the leaf nodes. Okay. Here you will have one more decision node. Here again, you will have two more leaf nodes. So here you have leaf nodes as well. This is one more decision node. That way it keeps increasing, right? You're getting my point, right? So the whole logic behind a decision tree is like a tree structure. It keeps increasing. Okay. In a way, your decision tree will try to mimic the thinking, like whatever we think as humans. Okay. So what are we supposed to be looking at? So we have root node. Root node is the start point where it all started, right? Right. This is a root node. And then you also have leaf node. Okay. So leaf node, you can say them as output. Right. And then you also have something called as, let me clear this up. You also have something called as splitting or split. Okay. So it will divide your decision node. Okay. And these are again divided into subnodes. Okay. And you also have branches. Okay. And there is a concept called pruning. Pruning is when we eliminate the branches that are not required. Okay. Let's say you have these branches and you can simply eliminate them. Okay. You also have child node, right? Okay. You can look at the data set and then it keeps your decision tree algorithm. It will compare the values. Okay. And it will compare the values with your actual data set. Okay. And based on this comparison, it will move to the next node. So where does it start? Right from the root node, right? And then based on that, it will get divided. It will, get into the sub nodes, right? Or subsets. And then the decision tree gets started. Okay. For example, let's say a customer is planning to buy a car. Let's say this is a car. Okay. So he wants to decide whether he has not made a decision yet. He just need to make a decision whether he wants to buy a car. Okay. And based on what scenarios should he accept or on what scenarios should he decide on buying a car? Is it the brand he is looking, or is it the performance, or is it the color, the category of a vehicle, right? So these are few things that he should be looking at. Okay, so if you put all of that, this is a car, or yes, does he want to buy or not, like this, or let's say he's making a decision here. Brand of the car. Okay, or color of the car, right? So here if he is looking for a brand, you say yes, or if he is not looking for a brand, okay, which brand? So again, so look for, yes, he is looking for brand. What kind of brand? So here again it will be split. Okay, so here let's say some XYZ brand. If it is not, then if it's not looking for brand, then he'll not buy a car. He'll simply decline it. Okay, and if he's looking at the car, does this brand have these options, right? What are the models? Something like that. Okay, if there are no, if this model, if this brand does not have this model, then he will not buy the car in that particular brand. Right, so these are certain things, or this is the data that you require. Okay, this is the information you will be looking at. Okay, and so all this calculation will allow to get you the class of the data, and based on the value you split the nodes. Okay. Based on those nodes, you build the decision tree. Okay. Right. In pruning, what you do is you delete the unwanted nodes, right? We already talked about it. Okay. And in pruning, you also have something called as cost complexity pruning and reduced error pruning. Okay. And your decision tree model is for your, it is very apt for your decision related issues. Okay. And it is used for, or we can say that, okay. And you also have one more alternative for this. It is random forest algorithm. Okay, let me clear this up. Right. So in decision tree, you have these layers, all these complicated layers. And if you look at a brighter side, whenever you're dealing with decision tree, you don't have to worry about the data. That means data processing, data pre-processing problems are or less, or you are dealing with not so large data. Okay. Like your data cleansing, you do not have to invest that much of your time. Okay. And it is related to the decision making of similar to what we take as a decision. We humans take a decision, right? It is related to similar attributes. Okay. And also, if you have, for example, let's say if you have a decision tree, it's huge. And then there are chances that your model is overfitting, right? And You can also look at the, or you can also look at reducing the accuracy. Okay. And the process of reducing the accuracy, or reducing the accuracy is called pruning. Okay. Right. We talked about reducing the accuracy rate. Okay. And if you talk about the training or the inputs, you'll be looking at very less inputs. Okay. And in pruning, what you can do is how to identify unnecessary parameters or the data features is something which the data which does not have any significance. Okay. That will help in pruning. And also, if you look at the benefits or ease, it can be used, or it will allow your numerical data as well as categorical data. Okay. Right. And non-linear relationship between parameters will not have any kind of effects on the result, basically. And even if there is a slight disruption in the data, or slight variation, it will have an impact on the outcome. That is evident. Okay. And the difference, this is called a variance, and this can be avoided, or this can be lowered by the technique called bagging and boosting. Okay. Okay. We can train on the number of customers if we want to, We can take 100 customers and then you can train them. Okay. And then you can start up on the notes. What kind of these 100 customers will end up deciding is what we can do. Keep your data like closer. Okay. Also, you can look at these type. Let me just give me a minute. Okay. Right. We talked about a numerical data as well as categorical data, right? And it is user friendly, interpretable, okay? And there are certain libraries we need to use. Okay, I will talk about few, which is pandas, and also I will take you to the code. Let me switch. I will import pandas as PD. Okay, import numpy as NP. So these are few libraries that I'm importing. Okay, from sklearn dot preprocessing import label encoder. Okay. Now I'm importing the data here. I will copy the path and then let me get the data quickly. So always remember to replace your backward slash with forward slash. Okay, I will pass the file name as well. And then I will replace these backward slash with forward slash. Now I would like to import the data. So now next I will drop the, or I'm looking at the null values. Okay, I will drop the null values if there are any. Okay. Data dot drop NA. Okay, data dot columns as well. So these are the columns that I have. See, these are the columns that you see in the console. So what are the features that I would like to drop is what I will pass. I will say supplier ID, job title, job title. Okay, and then I will execute this. Or I will say supplier ID is what I don't. Okay, see, I don't have, if you look at the data, I don't have supplier ID feature in my data frame. Next, I will say DESC is equal to data dot describe. Okay, now this is the data that I have. Okay, now I want to convert the data, the features into numeric values, categories into categories. So these are few. Okay, I will say shipping mode, credit card is what I want to. Credit card mode as well. Okay, these are few features that I will be converting. Similarly, I will be doing with this all these features. Now I will say see, and I want to transform others as well. I've transformed it. Okay, and then I want to look at the unique values. Okay, I also have predictors and target. Okay, and I would like to predict from these columns. Okay, I'm saying I'm passing a index here. This is what I'm doing. Okay, and then I train the data as well as test. I keep doing that, and also you'll have to do. You should predict the train data as well. Okay, and then auto tuning, which is your hyperparameter tuning. Okay, with the help of grid search, I'm doing this. Okay, I'm saying grid underscore search. I want to fit this model. Okay, and once I've done that, I want to evaluate the train data. And once you have evaluated the train data, you then predict the test data as well as you predict the train data. Okay, and if you look at the visualization, this is what you get. Okay, so these are the parameters that you need to be passing. Okay, you say these nodes that you should be passing. Okay, and clean the data, and it does not require much. You don't have to look at it, as we already know. It does not take much of that. It is easy that way. Okay, here I'm using a random search, grid search for my uh, hyperparameter tuning. I mean, along with hyperparameter tuning, I'm also doing a grid search, random search. Okay. You can also visualize in the plots column. You can in the tab for any kind of data visualization. Right. The optimal decision cannot be like finalized. Okay, you'll have to do the, you have to stick to multiple decisions tree, or you cannot be doing it on a single one for a optimal result. Okay, you have to train multiple decision trees. Okay, and one of the drawbacks in your decision tree is it cannot generalize the data in certain way, right? Okay, and you can also, if you look at the libraries, you can also try with sklearn. You can also look at sklearn, that is nothing but scikit-learn. Right. All right, guys. uh, okay, friends, we will stop our discussion here for the day. Okay.